the length of 10 ohms of copper wire whose diameter is 3.22 millimeters. Rut-row. So we have one of these diameter problems. Let's give this a shot. Let's define what diameter is. Diameter is still 2 times the radius. So what is the length? Let's find our friend. See if our equation's still in memory. There it is. That's great. So what is the length? Let's manipulate this for length first. Length will be, let's do some algebra here. R times the reciprocal of this, A over rho. So we'll sub in now. Length will be resistance times area. That's pi r squared. Got to be careful. Resistance is r and radius is r squared. So let's do one thing just so we keep things clear. We will use a lowercase r for radius in this problem. So I'll come up and rewrite. We don't want to have 2 capital R's. That will become very confusing. At least to me it is. Divided by the resistivity. So now we're good. Let's give it a shot. Length is r times r, and area is pi r squared divided by the resistivity. So now we're going to solve this in terms of diameter. What is r? R is diameter divided by 2, and r squared is still d squared divided by 2 squared. Oh, that's messy. Divided by 2 squared is 4 still. So I'll rewrite. Length is resistance times pi. What is r squared? That's d squared divided by the whole shebang, divided by 4. And we still have that resistivity in the denominator. So what is resistance? That's 10 ohms times pi times the length, or equals the length. What is the diameter? 3.2 millimeters. 3.2 millimeters are 3.2 times 10 to the negative 3 millimeters. So we have to be careful here. That's the diameter in meters. So we'll write that. 3.2 times 10 to the negative 3 meters, quantity squared, divided by the resistivity, 1.68 times 10 to the negative 8 ohm meters, times 4. So this is a problem where, you know, you're going to get an answer. Let's take a peek at what the answer is. A long distance in meters, about 5,000 meters, 4,787.2 meters. So let's see if we can approximate this. Sometimes I'll cheat and approximate answers without using a calculator. 10 ohms, or let's do the units first. We have ohms over ohms, that cancels. Pi is a constant, it does not carry units. So we have meters squared divided by meters. That will give us meters. So the units will work out. So we're good to go there. Let's approximate. What pi is 3.14. Sometimes in my world I'll just call that 3. What is 3 times 10? That's 30. So we're accounting for the 10 and the pi. Next we're going to square everything inside of the parentheses. What is 3.2? That's almost 3. So what is 3 squared? That's 9. What is 10 to the negative 3 squared? That's 10 to the negative 6 divided by 1.68. I'm just going to call that 2 times 10 to the negative 8. I just round everything. Divided by 4. What is 2 times 4? I'm going to call that 8. What is 9 divided by 8? Oh, let's just call that almost 1. So that will leave us with, let's just highlight what's left. We're left with the 30. We're left with the 10 to the negative 6 and the 10 to the negative 8. We're going to be off by quite a bit in this approximation, but we'll round it to the nearest order of magnitude. That's how I'll bail myself out. So what is 30? We'll just write that out there. That will be 30. And then what is 10 to the negative 6 divided by 10 to the negative 8? So when you do that, it's 10 to the negative 6 minus negative 8. That's negative 6 plus 8. That's 10 to the 2. What is 30 times 10 to the 2? That will be 3 times 10 to the 3. So I got an answer that's approximately 3,000 meters, because I'm approximated quite a bit. I've made quite a few assumptions, which errors propagate continuously. But really, what's the best answer? 10 to the 3 meters. If I approximate this to the nearest order of magnitude, and you'll be a lot more precise, you'll get an answer closer to 4,787.2 meters when you use a computer. But I found that my answer, 3,000, is close enough to 5,000, because this is also of an order of magnitude 10 to the 3 meters. Okay. We realize that I'm off by a little bit, but we'll deal with it. Again, big picture here. Use a systematic approach. Ooh, that's a lot of problem solving. Use a systematic approach to problem solving. Write what you know as a starting point. Manipulate. Again, if you don't have a variable to solve for, you use the system of equations. Write what the diameter is in terms of the radius, and then sub it in, solve for the unknown based on what you're given. Do the conversions. Approximate if you have to, especially if you don't have a calculator, and you'll be home free. A lot of work on that problem. Let's stop this video for now before we go on.